Hello everyone. So, Mausam, you sent me some photo. It was breeder seed, foundation seed, certified seed. What is it like? What you wanted to ask? Yeah, you read it somewhere. You didn't get the meaning of it. Okay. So let me just share this one first. How do I explain this? Okay. Where can we find all these live sessions? So actually, these are free sessions that are being conducted in our AgriEdit app. As of now, we have planned to upload all the video lectures for this seed tech to the YouTube, but I think we have only uploaded 6 to 7 lectures. Rest of them we want to upload it, but they are still in editing mode. So soon after the editing is done, we will upload it in the YouTube and we'll just notify it. And it won't take much time. We'll do it in this week only. Okay. But the notes, if you are willing to have these notes, either you have to buy the master course or you have to register for seed science and technology course separately. So we don't have any opportunity to give, or we don't have any choice way of circulating the notes through the offline mode. Okay. So there was one question. I will just discuss the question and then we'll move forward. So it is saying that breeder seed, it is given as A, B, and R, and foundation seed is also given as A, B, and R, and CS certified seed is given as A, and R. So this is what it is, I think. Okay. So can anyone just tell me like what is the meaning of this? This is ABR and this is A into B and R separately, and this is A into R. So this is for hybrid seed production. If anyone has understood what does this mean, so you can either unmute or you can also text in the chat box. So just take a screenshot of it or just make a note of it. We can discuss it at the end of this class. I'll just give some time for you people to think and I will just address it later. Okay. So why I shared this particular document was like in the previous class, before the previous class, one of the student has asked me to just highlight the important things that are to be covered in this IMSS guide. So this is a document which is freely available for you people in the AgriEdit app. If you just visit the free material section, you will find this particular document, right? So you can just download this document and take a printout of it, because you can expect at least 1 or 2 questions from this particular document itself. So this document covers isolation distance of all the crops, germination percentage, objectionable weeds, and designated weeds. So these are the 2 different things which I was talking about yesterday in the seed production class, where when we talk of seed production, what are all the things that you should understand and remember is its pollination biology and its isolation distance and its seed standards, which are objectionable weeds, designated disease weeds, and germination percentage, and if there are any pure seed percentage, physical purity percentage, and genetic purity percentage. So these are the certain things which you should remember, and any specific cultural methods if they are available. And method of hybrid seed production. Along with the varietal seed production, you should also know like what are the different hybrid seed production technologies that are used in that particular crop, in whichever crop you are dealing with. So all these things are very much necessary, and that's it. You need not to go for the agronomic practices, how the soil is tilled, and what are the things that are done, and also about the seed source and the land requirements and everything. You need not to worry about, and fertilizer requirement, nutrient requirement, and irrigation requirement. So these things are not much necessary, but these are the things like which I've told you. These are very much important. You need to take care of all these things. Along with this, they might also ask you like how many field inspections are generally conducted in case of field crops. There is a concept called as field inspections. So there is a generalized criteria where self-pollinated will have 2 to 3 field inspection in total during the over the period of seed certification, and cross pollinated hybrids and often cross pollinated will have minimum of 4 inspection. So this is minimum. Maximum, it depends on a seed certification officer or state seed certifying agency. It can conduct as many as inspection that it feels required, but minimum is 2 to 3 in case of self pollinated. In most of the crops they follow only 2 field inspection, and for the cross pollinated hybrids and often cross pollinated, generally 4 inspection is followed. So first one will be during sowing, and this is pre-flowering, and next will be the during the flowering stage, and lastly during harvesting stage. So these are the different stages where the field inspection is conducted in the cross hybrids and also often cross pollinated. So this is one addition to what I have said yesterday, including all these parameters. You should also take care of number of field inspections. So out of this number of field inspection, I also told you the number of field counts for the while taking the field inspection, how many field counts are there, and this depends on the area. It starts with I think 5, 6, 7, 8, and 10 and above, right? Up to 5 hectares, 6, 7, 8, and 10. So how many how many counts are done? So you need to take care of all these things. Okay, I hope this is clear. So I was discussing about the crops list. I will tell you like what are the things that you need to take care of. For example, for the paddy itself, you see 4 different columns or 4 different rows, right? Then out of these 4 different rows, which should be which row you should concentrate. The first and foremost like importance should be given to the first one. This is the variety. So what is the full form of A, B, C, D? Everything I just mentioned in the above abbreviations list. So here you can clearly see that A refers to the field of other varieties, B refers to the same variety, but it is not confirming the standards. What does this mean? It means that if there are 2 different seed plots, if one is is undergoing the seed production, and other one is just a similar crop with a similar variety, let us take it as assume as a rice, and the variety is Aruna, and this is also same variety. But if this second variety is not conforming to the standards, then the isolation distance between them changes. It would be similar to the fields of other varieties, and the other varieties or the same hybrid, this is C, and same hybrid not conforming standards. So these are the abbreviations. So out of this, so like many times, like I have seen the questions from Johnson grass and sorghum alpense, and also the fields of wheat, they will usually ask, and the different kernel texture and tears intake. So this I have seen it. So this always create the confusion. They will usually ask you that what is the isolation distance for the maize having the same kernel color and texture, and what is the isolation distance followed for the maize with a different kernel color and texture. So these are some confusing terms. So you need to concentrate on E, F, J, and this forage sorghum. And this first is very important. This is very basic and important. Usually direct questions comes from this first one. Like if they won't tell you the any abbreviations, if they won't tell you the conditions, like whether it is field of other varieties, same variety, or other variety or same hybrid or anything, you should consider it as fields of other varieties. If I ask you like what is the isolation that is distance that is maintained in the maize, you should inherently consider it as from the field of other varieties. Clear? So this is regarding the IMSES crop standards, where you can clearly see I have mentioned all the different parameters with the abbreviations ABCD, and also the germination percentage, designated diseases, and objectionable weeds. So if you just observe very carefully, the designated diseases and objectionable weeds are not present for all the crops. That is what it makes unique, and they will definitely concentrate on these designated diseases and objectionable weeds. So make sure to, I already made the list. You need not to worry about anything. Just take a printout of it and revise it from time to time. That is what you should do. See, you are getting the diseases like in the sorghum. The designated diseases are ergot, gram, and like kernel smut. Like it's grain smut. Sorry, grain smut or kernel smut. The egg smut, and next it is ergot again in the bajra, and downy mildew or green ear of bajra, grain smut. So these are the list of diseases which are limited to specific crop. Not for all the crops we have the designated standards or designated diseases. So make sure to don't again make the list, just follow this list and just try to revise them from time to time. Okay, so this is what I wanted to discuss before the start of today's class. I hope it is clear. If not, you can just text me in the WhatsApp at any time. This is the number I have provided here. So I'll just answer your queries. But I will tell you, like I can bet you that you can definitely expect 1 or 2 questions from this particular table, either from isolation distance, germination, designated diseases, and objectionable leads. So I have told you that I will also include the planting ratio and SMR. Along with this particular table, I will also include those 2 different tables, so that at one place you get all the parameters, right? Previously, I have not done it because the planting ratio and the SMR is not prescribed by this IMCS. So it is prescribed by the government, but not by the IMCS. So that is why I have not included here, so that it won't create confusion. But I feel now like everything should be at a one place. So I will just add extra columns here, and I will just give you the planting ratios and the SMRs. SMRs and the planting ratios are as equally important as this all other parameters. So if you have gone through the previous year papers, you will definitely see the questions from either SMR or planting ratios or objectionable weeds, designated diseases, germination, and isolation distance. So make sure to follow them. Okay, that's it. What I wanted to discuss about IMSCS. So coming back to today's class, today we are going to discuss about the post-harvest operations, where we will start our discussions from harvesting until the seed storage, and we'll also talk about the gene banks. So I hope like you people already know it. Like once the crop is harvested from the field, after harvesting there are certain process that are needed to be done. So once after harvest, we know that the threshing and the seed extraction is done. After the seeds are extracted, we just usually dry the seeds. Why the drying is done? To lower the moisture content. So why the lowering the moisture content is important? Because during storage, if the moisture content is high, it is more susceptible to the insect and pest, because it provides a favorable environment for pests and the diseases to attack and to infect the seeds, and they will spread over complete seed lot will be spread over. In the due condition, like it will eventually lose the quality. So that is why the seed drying is important, where the moisture content is usually lower. So once the seed drying is finished, we will process the seed. So then why the processing is important? We know that there might be the mechanical mixtures, and there might be, if the threshing or if the harvesting is been done by the machine, there will be always trash, clods, pots, stones, and everything that is intermixed with the seeds. To in order to clean them and also to upgrade the quality, to make the seeds of uniform size, based on the size, weight, length, color. So we need the processing. That is why processing is very important, because in the market, whenever the farmers want to buy the seeds, he will just look at the seeds, so whether it is uniform or not. So only the uniform seed lot will attract the buyers, and also like it is already fixed that if they are uniform, they will be of good quality, and they will have the uniform germination stand or uniform yielding ability. So that is why this seed processing is very much important. Once the processing is done, these seeds are usually treated, like seed treatment is done. Why the seed treatment is important? Again, to avoid the attack of pests and diseases, insect pests and diseases during storage. Anyhow, the complete seed lot will not be sold immediately after the cultivation. We know that even immediately after the seed production, not all the seed lots will be sold. They will be stored for at least 3 to 4 months until the next season. So during seed storage, the quality might deteriorate because of the susceptibility of the variety. So in order to avoid that, the seed treatment is usually done. So there is a new concept called as seed invigoration along with the seed treatment. So what is seed invigoration? Invigoration is enhancing the quality of the seed. So that is what seed invigoration means. So can anyone tell me if you know any of the methods that will increase the quality of the seeds, or it will just increase the germination capacity of the seeds? I'm just giving you the int. Just take a int as germination capacity. Usually we also have some traditional methods that is even followed from the ages from by the farmers. That will also come under the seed invigoration concept. Yes, I expect some answer for this particular question. I hope like many of you are from the rural background, so you might be knowing this already, but I don't know whether you were able to catch it or not. Yes, I'm expecting some answers, please. Okay, no one knows about it. Seed invigoration. See, forget about seed invigoration. It might be new term for you. Like, but what are the different methods that we follow to increase the quality? Moisture reduction. Yeah, like okay, moisture reduction is fine. That is in the drying itself. But what else? Like think. Yeah, it's good that you are answering something, but think of it. It's very simple. Yes, exactly. It's seed priming. I hope like everyone knows about priming, right? What is priming? Priming can be of hydro priming, where you just soak the seed overnight before the sowing. So this is a one traditional method that is followed from the ages, where it will have the impact on the germination ability. If we pre-soak the seeds before sowing, it will have the uniform plant stand, or the germination will be uniform, or it will be fast. The duration of the germination will be early because of seed imbibition. So what is the process that actually occurs during seed soaking? There will be a seed imbibition, like imbibition of the water, which is a physical process. So imbibition of the water, what is the effect of the imbibition? I have talked about this in the seed physiology class. So imbibition of the water will activate the enzymes in the seeds and make it prepared for the germination. So that is what seed priming means. Like, seed priming main objective is rapid germination of the seed lot can be done just by soaking the seeds. And again, seed priming is of different types. We also have the osmo priming, hydro priming, and also solid matrix priming and other things. But generally, the priming is just enhancing the quality by increasing the germination or fastening the germination. So this is again a type of seed invigoration. Term may be new, but the practices are already followed from the ages. Okay. So next we have the seed packaging. Once everything is done, we need to pack it in a suitable package according to the conditions where we are storing. So if we have the good storage conditions, we need to do it in a. You can also do it in the gunny bags, which where the storage conditions is optimum itself. Or if we are going for the cold storage, the packaging conditions should be in a vapor proof, so that there would be exchange of any moisture. And this is why this seed packaging is important. Next, it's about seed storage, and there are certain parameters or certain conditions that we need to follow, or that certain factors that we need to consider before storage, because seed storage is the one and like foremost important thing, because most of the seed deterioration will actually occur during the storage. Either it might be destroyed through the rodents or any other pest or insects diseases, or because of limiting environmental conditions, either might be because of high temperature or low temperature, or due to the flood, rain, anything like so. That is why the storage conditions are very much important. Okay. So someone was asking about what you call xenia and metaxenia. I hope like I have answered this in the seed physiology class. Can anyone tell me if you remember what is xenia and what is metaxenia? Not seed physiology, I guess. I talked it in the genetics class. I hope you people are attending. You attended the genetics class. I don't know like how many of you have done it. So What is xenia and metaxenia? You want me to tell it again? Okay, that will be very much different from now. So okay, we'll discuss it anyhow later. So coming back, I was talking about the storage. Next, after storage, we'll talk of the gene banks. Gene banks are very much necessary. It will buffer stock. It will act as a buffer stock of all the germplasms, so that it will be stored for longer duration, so that no variety will go extinct. We'll start our discussion with the harvesting. Introduction. I have just taken 20 minutes of your time for just introducing the outline. Oh, okay. So starting from the harvesting can be of a single picking or the multiple pickings. Multiple pickings are usually followed in case of cucumber, like vegetables, pulses, and cotton and other crops. Like majorly, it's on the vegetables, cotton, like pulses and the cotton. And the single pickings are for majority of the agriculture crops. If there is a single picking, we go for the machine harvest, or if it is a multiple pickings, we go for the manual harvest. So once the harvesting is done, what is the next procedure? So once harvesting is done, it's about threshing. So can anyone tell me the difference between the threshing and seed extraction? Or example where we actually do the threshing, and examples for where we follow the seed extraction directly. Or it is a sequential procedure where we go for harvesting, threshing, and seed extraction. Okay. Actually, I want it to be very like interactive session, but since the time is a limitation, I cannot wait for you people to answer for each and every questions. I have to rush into the things, because if not, I won't be able to cover all the things that I want to deliver. So in between, if you get a chance, just please reply. Okay. So it's about what is the difference between threshing and the seed extraction. The threshing is for dry fruits, where we go for threshing. For example, panicles. In case of rice, we just thresh it manually and we collect. It's a caryopsis, right? So the wet fruits, usually we do the extraction in case of chili, tomato, and several other vegetables, right? So extraction can be either dry extraction or the wet extraction. Wet extraction is by the means of the chemicals or the acids or the alkali, or the fermentation process that we can use. Or dry extraction is just by beating or the manual work. Okay, so this is about threshing and extraction. So what are the different instruments or the different machineries that we use for the threshing? We have rubbing and sequencing, and it is in case followed in case of these particular crops. And there is a manual method of beating, and this is followed for the pulses. Stripping, you might expect this question in the exam. The stripping is familiar with the groundnut. And we also have the trading, which is for cereals and pulses. Trading is nothing but spreading the stock on the hard surface and just applying some force on it. So these are some methods. And there is another method called as flailing and pounding, and this is followed in the rice. So it's nothing but just beating the small, like the panicles are bundled with the tied with a certain rope, and they are just beaten with a piece of wood. This is what flailing and pounding means. And also, like, we have the animal threshing. I hope like you already know it. Next, we have the tractor or the power tiller, where the threshing is can be done by trampling means applying the pressure, like tractors or power tillers or any others, like goods or like animals. Use of the animals will be done just to apply the pressure on the ground, where the on the ground all the harvest material will be spread, and to that the trampling is done. And now recently we have the modern power threshers, which are machine made. And we have automatic threshers like pedal thresher, drum thresher, multi crop thresher, and also like paddy thresher, and the crop specific threshers we have. So this is how the seeds are extracted once they are harvested. Okay, so talking about the extraction, it is of dry extraction and the wet extraction. Dry extraction, you might take an example of chili. So dry extraction can be because of by the help of the bamboo sticks or beating against the hard surface. And here also the threshers are also usually used in this dry extraction procedure, and this is very common to all agriculture crops. So wet extraction is for the tomato, brinjal, bitter gourd, and the different gourds, or the cucurbits, or the more generally it's a vegetables. So where we need to extract the seeds, it is since it is present in certain fruit structure. And they are usually washed with acid, which is normal, like which is generally the HCl. It's 0.1% for 2 to 3 minutes, and this is how it is done. So talking about the chili is a dye extraction by using the curry powder. There is a grinder called as curry powder grinder by the use of which we will just thresh or extract the seeds of chili. When it comes to tomato, you might expect this question from in the exam, like how do we extract the seeds from tomato? The tomato, we have fermentation, acid method, alkali method, and also we use the citric acid, but these two methods is not economically feasible. That is why we don't use it. And also the fermentation, what is the major backlog of this fermentation? The fermented seeds will be the dull in color. As I told you, it won't attract the market or the buyers if it is dull in color. So this color related compounds or the aspects are again related to the yield and other major morphological and other yield characters. Since they are again composed of the antioxidants, they play a major role during the development. So that is why if they are dull in color, it simply means that they are not of good quality. So that is why the fermentation is not even followed commercially. It is the acid method by the use of HCl, which is 10 ml per kg of pulp, which is more commonly used commercially for extraction of tomato seeds. Okay, so this was about threshing, extraction, and what else? Next, it's about drying. So why usually dry the seeds? I told you, like drying is very much necessary to lower the moisture content. So why the lowering the moisture content? Because it will maintain the vigor and the viability. It will be viable for longer period only if it is lowered, like only if the moisture content is lower. So why to lower the moisture content? To avoid the attack of insect, pest, and diseases. So again, the drying temperature depends on the initial moisture content. If the initial moisture content is up to 10%, the drying temperature is either 110 degree Fahrenheit or 43.3 degrees Celsius, or if it is 10 to 18, it is 42.2, and 18 to 30, it is 32. So you should remember that as the moisture content increases, the drying temperature decreases. If you simultaneously increase the moisture content and increase the drying temperature, there will be a membrane rupture because of the increased moisture content that is already there in the seeds. It will be already bulky in nature. So if you just give some shock to this particular seeds, there will be a membrane rupture. That is why as the moisture content increases, drying temperature decreases, but the duration of the drying temperature will increase with the increase in moisture content. Yes, the drying temperature decreases with the increase in the moisture content, but it has to be treated for longer period of time so that there will be a gradual decrease in the moisture content. Okay, and one important thing to be remembered is the drying temperature is of maximum 43 degrees Celsius. For any agriculture crop, whenever you are going for drying, you cannot exceed the temperature above 43 degrees Celsius. It should be always below or equal to 43 degrees Celsius. So you can expect this question, just try to remember it. Next, types of drying. So what are the different types of drying? One method we already know it, it's a natural drying or the physical drying. The natural drying is nothing but a sun drying, but what are the disadvantages of this particular drying? See, when you are waiting when you are doing the natural drying, you should wait until they are dried in the field itself. So there will be automatically delay in the harvest. So there might be a risk of weather damage, and also the mechanical admixture can occur because of delayed harvest in case of physical drying or sun drying. So we have again the mechanical or artificial drying, which is divided into force natural air drying, force heated air drying. In this heated air drying, we have the metal bin dryers or the batch bin dryers, and also we have the continuous flow dryers. So you need not to worry about the mechanisms and the principle and about all these things, but just try to remember the names. So we have LSU dryers, that is particularly for paddy. Okay, this is the full form. It's from the Louisiana State Universities. That is why the name LSU. Okay, so the difference is these are just in the box type dryers, and this is a continuous flow dryers. Like the heated air will be continuously circulating, and this is how the moisture content will be lowered. So there are certain important points. So which I already told you, like the temperature cannot exceed this 43.3 degrees Celsius at any cost. A drying temperature should be always less than 43.3 degree for any crop. Okay. So there are other points. Sun drying. So even if we talk of sun drying is only possible wherever we have the long sunny days. that is available in the tropical climates. But even in the tropical climates, if there are continuous rains, this method cannot be adopted. We always have to go for mechanical or artificial drying, right? So these are other things like bin dryers and bag dryers. You can just read it by phone. So this was regarding till drying. Once the drying is done, now what is the next step? It's about processing the seeds. So the processing, once once the processing plant receives the seed lot for processing, these are the different sequence, like different machines that it moves across, and until it reaches the storage. So first, when the seed lot is received by any seed processing plant, first it will be preconditioned. The preconditions or the pre-cleaning refers to removal of large trash particles like other trash, clods, stones, chaff, inert material. This is nothing but if the size of the crop, the materials which are more than the size of the crop will be removed in case of conditioning and pre-cleaning. It will just improve the physical appearance of the seeds. So this is what pre-cleaning means. So to be more specific, this is a sequence. Whenever the seed lot or the seeds are going into the processing plant, it is the pre-cleaning first. After the pre-cleaning, there is a basic cleaning, and then there is a upgrading. So you might have heard about the several machines like a gravity separator, roll mill, indent cylinder, and inclined draper, cylinder separator, spiral separator, and electronic sorter. So you might have confused like where all these machines are, like under which category all these machines come. So all these machines which I've talked to you now will come under upgrading. So these machines generally used to upgrade the quality of seeds. So before upgrading, then what are the which are the machines that are used for the basic cleaning? It is always the air screen cleaner. This is very common to all the crops. It's a general purpose machine where the basic cleaning is done. Okay, for the pre-cleaning we have several machines. For example, just to remove the scalp, we have scalper, and we have Aller scarifier just to remove the hull and just scratch the seeds, and we have debearder, pebble mill, maize sheller, Timothy bumper mill, and this is specific to certain weed, and we have hammer mill, buckhorn machine. So this is again specific to certain weeds. So these are certain preconditioning or pre-cleaning machines that are available. See, if there are no machines which are very specific to the crop, scalper is used. Scalper consists of the screens, like the how we see with the dots, screens with the dots where the seeds are dumped and the large materials will remain here, and the short seed particles will come lift or drop out from these indents. So the indents can be made up of wire mesh, like just like a mosquito net. It can be made of wire mesh or the metals. Even it can be made up of metals. But you need not to worry about all these things, but you should know it, right? So this was regarding the scalper. And next, I just mentioned in detail about all these things, though it is not required, but you can expect one or two questions. There are no that direct questions that can be asked. That is why I'm not explaining this, but try to go through this material once for the clear-cut understanding of all the different machines that are used. So there is one thing which is Aller and scarifier. So why do you think the scarification is necessary, or what is the impact of scarifying the seeds? Whether it will have the positive impact or negative impact. I hope like in the screen you are already able to see it, right? I mentioned the two important advantages of scratching the seed. So scratching is just nothing but rubbing the seed on a hard surface. So why do we do it? So it will increase the permeability to oxygen and the water, in which the imbibition rate will increase. And secondly, it will remove if there are any growth inhibiting parts or the substance or the chemicals that are present in the seed coat. So ultimately, what effect it will have? It will hasten or fastens the germination process. So this is the scalper. This is how scalper looks like. It will have screens. In this particular case, when in the feed hopper, the seeds are dumped, and due to the vibrating action, the scalper will scalp the larger materials in the upper level, and all the seed materials will drop out from the indents or the pores. Okay, so this is how it is cleaned. So there are other pre-cleaning machines. You just go through them all once. I won't be explaining it. So this pebble mill, you can expect one question. So just like if you have observed the corn, it will have the webby ears in while it is harvested. After harvesting, you will definitely see the webby ears on that. So to remove those webby ears, usually the pebble mill is used, and this is for bluegrass and other similar grasses. And this is for just for the example that in the corn you might see the webby ears that are attached to the seeds or this cob, right? So those type of thing materials will be removed by this pebble mill. So what it usually does, there are stones that will usually roll and fuzz into the small round balls, and eventually these pebbles are removed in a circulating motions. If you uh, apply the seeds, or if you apply the stones or put the stones in a rotating cob, then definitely the airs that are present, it will roll on to the stones, and later you can remove the stones by the use of against the scalper or the screens. I hope like you people are getting it. Next, we have the basic cleaning. I told you the basic cleaning is by using the air screen cleaner, and that is a principle. On what basis that does this cleaning works? So it works on the principle of seed weight and seed size. So it will separate the seeds from all the other materials based on the seed size and the seed weight. So remember this particular point. You can expect the question. Seed size and the seed weight, air screen cleaner. So there are different parts of the cleaning elements: aspirations, scalping, and grading. Aspiration, it has the air circulation machine, and scalping, it has a different screens that are available, and the grading. Grading is done where underside cut, shriveled, will broken will drop again from the last screen, and the stable, normal, good-looking seeds will stay on the last screen of this particular machine. So the number of screens that are attached in this machine is can be modified based on the crop and based on the level of cleaning that you require. Okay, it's not fixed. I told you like screens, it can be made up of the wire mesh or the sheet metal. The wire mesh, it might be the shape of square or rectangle, or it might be, if it is sheet mesh, it might be round, oblong, or triangular. Okay, so how does this air screen machine looks like? So as I told you, so it can consist of multiple screens. So multiple screens, and also like the air circulating machine which will circulate the air, so that only the lightweight seeds will be lifted and the heavy seeds fall off. So this is how, based on both seed size and weight. So weight is mainly because of air screen, and the size because of the ports that are present here. The larger size will remain and the smaller size will drop off. So this is how the cleaning is done in case of air screen cleaning machine. Next, we have upgrading. So this is foremost important thing to be remembered in case of seed technology. So you can definitely expect some questions from the upgrading machines, where they will directly ask you like what is the principle, and what principle does the gravity separator works, and what principle does the roll mill works, and what principle does this indent cylinder separator, or inclined draper, roll mill, and also spiral separator, all these things works. So make sure to remember them. Okay, so we have the list where it starts with the width and thickness, and nextly we have the length sizing, grading, in which the length sizing and grading, the equipment is disc separator and cylinder separator. As I told you now, so disc separator and cylinder separator works based on the principle of length and size. Length sizing, like usually it is based on the length of the seeds. The seeds will be separated. So if in the exam they ask you like, okay, the seed lot is actually differing in their length, then just suggest a suitable machine through which we can separate the seeds. So then the answer would be disc separator or cylinder separator. And we have other machines for width and thickness. So these are not very common, you don't worry about it. So this is a indent cylinder separator for length separation, where you can clearly see. So this is a cylinder. These are the indents that are present all over the indents. The seed will actually, based on the length, they will just go and sit in these indents. And there is a needle which will rotate all over these indents. When the seed length is more, it will grab those seeds and this will fall off. If the seed length is exact to that of indent, it will be fixed here. so that it will be eventually separated from the long seeds or lengthy seeds. So this is how the separation works in case of cylinder indent cylinder separator, which works on the principle of length, like which separates the seeds based on the length. Next, we have a gravity separation based on the gravity or the weight. It is the gravity separator, and secondly, it's stoners. Stoners are nothing but the modified gravity separators. So how does this look like? Gravity separators. So this is what gravity separator means, where this is a feed hopper and this is the deck. This complete thing is called as deck, where once the seed particles are poured here, there will be a vibrating actions on this complete deck, vibrating action. So once the seeds are falling here, the heavy seeds will fall off to this particular eye end. This is called as eye end, and this is called as low end. So the light chaffy material and the lightweight materials will come to this light end. So you can also make a fraction based on the weight. You can also make the fraction where the heavy seeds will fall off in the first box, and next heavy seeds will fall off, second heavy seeds will fall off to the next box, second box, and so on. Like the light will be at the last box. So this is how the separation works based on the specific gravity, because of the vibrating actions or the weight. So next, air separation. So based on the air separations, we have a pneumatic separator, aspirators. So you don't have to worry about it, just leave it. Next, based on the surface structure of the seeds. So based on the surface texture of the seeds, we have mainly the roll mill, magnetic separator, and the inclined draper. So don't confuse with the inclined cylinder separator and inclined draper. So inclined draper is limited to surface texture separation, and the inclined cylinder separator is indent cylinder. So this is inclined. Earlier one was indent. So it was limited to length separation based on the length basis. So here the first one is shape and surface structure, and magnetic separator, it is specific that based on the stickiness of the seeds to the materials that are like given, based on that the separation occurs. For example, usually the sawdust is used or the magnetic particles are used. So once based on the stickiness of the seeds to this magnetic particles, the length or like the size of the seeds will vary. Once you are varying the size of a seeds, you can easily separate it by just by using the scalpel. So this is the basic principle of how it works. The low roll mill, it is shape and surface structure. The magnetic separator is surface structure and the stickiness. So the roll mill, this principle is very simple. So if it is a seed hopper, so this is in an inclined manner, like it is in the inclined manner where the heavy seed will fall off. Like this is rotating in this clockwise direction, this direction, both the things. This is the belt, where on the belt, if the seed follows, the lightweight seeds will be following, or the rough seeds, will attach to this particular surface, so they will be following here. But the lightweight seed will roll down, and smooth and lightweight seed will roll down and come to the other box. So this is how the separation is done based on the surface texture. If the texture is hard or rough, it will stick to the surface, right? If on whatever surface it is, it will stick to it for at least for some minute. So within that, it will just come to the end and it can fall off. But the smooth lightweight seeds will roll down and it will fall to the another end. So this is roll mill. So the magnetic separator, this is also very simple, where in the feed hopper they will include certain materials like which are having the magnetic property. So once it is done in the drum, everything circulates or rotates and it will be intermixed with the seeds. Only those seeds, based on the surface texture, if they are rough, they will attach the magnetic substance to it. So once they are attached, based on the magnetic field that is applied here, it will be separated. So the magnetic fluctuations will will be attached until the roll is ended, or the roller is ended till come the downside, and only then it will fall. But if it in first place, if it is not attached to this magnetic field or the magnetic surface, it will roll, it will just fall off to the longer length. So this is how the separation works here. Okay, just be attentive and just answer this particular question now. So this was asked in ICAR JRF exam 2021. I need everyone's answer. Like you people, I need answers from everyone. Yes, take your time and just try to answer this. Question two. Two. Okay. Two people have answered it. It's option two. What about rest? Okay. I hope like you have understood it. See, the both the statements are right. Why? Because the first one I told you, it is based on the surface texture and the stickiness. It is right. Yes, magnetic separator works on that principle. Secondly, if the insect damage or partially filled seed, even though if they appear normal because of the same size and shape, but they always differ in their specific gravity. So if there is a difference in the specific gravity, you can use specific gravity separator. Yes, both statements are right, but they are not interlinked. There is no connection between these two different statements. That is why sector 2 is a right answer. I hope this is clear. So what I have done is, like all the previous materials which I have already uploaded, I have included the questions right away after the concept, after each and every concept for CTech. So if you have already downloaded the material, please try to download it again once I notify you in the WhatsApp group. So I have not updated it in the app, so I will do it by today. Once after that, you just download it, so that immediately after reading the concept, you might be able to answer the questions, so that are already asked in the previous papers. So other separations, I told you, like there are other also separations which is basis on the color. We use the electronic color sorter. We also have the electrostatic separators, but it is in the still a experiment separator. It's not commercially used. Other separators, it is a spiral separator, polishers, picker belts. Like picker belts is nothing but on a belt there will be a, like you might have seen this in the factories, where on a continuously on the floor the belts will be rotating or the moving, and during the movement of these belts the seeds will be placed on that particular belt and it will be handpicked. The off colored or the large size material, short material, or the small size materials which is different from the variety will be removed manually by the hand. So these are certain other separations. So this is how the color sorter looks like, and this is a spiral separator. Based on the rotating motion of the seeds, you can expect the separations between the seeds. So the lighter seeds will be falling in a longer distance, and the heavy seeds will be falling in a shorter distance. So this is how the separation occurs using spiral separator. So same thing I have clearly mentioned with the machine principle general use. Not only about the principle, you might also expect the questions from their general and specific usage. So try to go through this complete table once. Okay. So this was regarding seed processing. Next is about seed treatment. So seed treatment, what should I talk about? Okay. So I just given you the term, meaning, benefits, that is fine. And we have types of seed treatment. We generally use seed disinfection. So what is a I hope like you know about the difference between disinfection and disinfestation. Festation means just removing the surface borne organism. Disinfection refers to the complete removal of all the fungal spores in more deeper seated tissues or in the seed coat. And seed production, what is the purpose? Just to protect the seeds from external influence of the other organisms, other microorganisms, or pest and diseases. Now we have seed treating products. The seed treating products are generally classified as mercurials and non-mercurials. So mercurials, again we have organic and inorganic, and non-mercurials again organic and inorganic. So the organic non-mercurials, the typical examples are captan and theram, and for the inorganic non-mercurials we have the copper carbonate, copper sulfate, which usually used against the wheat burnt. And inorganic mercurials, it is mercurous chloride, mercuric chloride, and mercuric oxide. So these are certain examples. So just try to remember them, the examples and what are the different types. That's it. That is more than enough. So note. So you might have seen this question, the sequence of application of different chemicals on the seed. If I give you the fungicide, insecticide, and or the bacterial cultures or the biofertilizers, so which one will you apply first? So the sequence of application is always the fungicide first. Just remember, it is always fungicide first, or next is insecticide or the bacterial cultures. Okay, so try to make a note of it. Next, commonly if there is any ergot infection, we generally use the common salt, or it is also called as brine solution. For the treatment, we use the 5% of brine solutions to treat against the ergot infection. And then generally the organic mercurial which is used against the grain smut, it is seracin and agarocin GN. Okay, so whenever these are treated with the organic mercurial, it cannot be stored for more than a month, so it will become poisonous. And also if there is any cracking in the seeds, that will make it toxic, and again the seed reserve seed reserves inside the seeds will deteriorate. So that is why they cannot be kept and for longer period. They should be immediately sowed if they are treating with these particular chemicals. Talking about the formulation that we used in the fungicides, like it's usually dust or in the form of slurry or in the form of liquids. Next, we have the coloring of seeds. So why do you think like we generally color the seeds? So if you just think of like why do we actually color the seeds, it's basically serves the two purpose. So one is it gives a warning that just by seeing the seeds, the like farmers or any other people or a person will understand that these particular seeds are treated, that should not, these are not for the edible purpose. Otherwise, usually what the farmers and other people do in the market, they just taste the seeds, like they'll just eat the seeds wherever they get. But we need to take care of the thing that whether they are treated or not. If they are treated, then definitely the chemicals are always harmful to the human health. So that is why the coloring of seeds will give you a signal or the suggestion that okay, these are treated, we not use it for edible purpose. So second one is, this is a visible mark of evaluating whether the treatment is given to the completely, like the chemical is completely covered in the seeds or not, whether the seed is covered by the covered by the chemical completely or not. So this is also a second significance of coloring the seeds. Next, I told you about the seed invigoration. So what do you mean by invigoration? Invigoration is nothing but making strong the healthy seeds with a full of energy. So these are certain post-harvest treatments to improve the germination and the seedling growth. If I talk of physical methods, it is of magnetopriming. So treating the seeds with the magnetic field will activate the enzymatic system. So this is how it will influence the germination. And the irradiation, which is by the electron treatment, it is also having the similar effect. And we also do the manual seed sorting, so that will improve the germination. Next, we have physiological methods, which is pre-hydration or the seed hardening. Seed hardening is nothing but like simultaneous wetting and drying of seeds. And seed priming is also similar kind, where we follow like hydropriming, allopriming. Allopriming is salt. Biopriming, ospriming is again use of osmanticants, and we have solid matrix priming. So these are certain methods we usually follow for seed treatment in the seed invigorations. So we have seed packaging. So packaging, I told you there are three different classifications, which are moisture and vapor pervious, where it will allow the water and the vapor, like water in the form of both vapor and the liquid. And this particular packaging material is only used for short-term storage, and it is gunny bags and cloth bag. Secondly, there are moisture impervious but vapor pervious. That is, the moisture in case of like in terms of liquid is prohibited, like inhibited, but in the form of vapor it will allow it. like it cannot inhibit in the form of vapor. So those type of materials, it is called as moisture pervious but vapor impervious. So these are 300 gauge aluminum foils, like the gauge is 300. Below 300, these are the packaging materials. So we also have the moisture and vapor proof containers, which are generally used in the cold storage. For keeping the seeds in a cold storage conditions, we usually use this one. They are aluminum foils of 700 gauge, more than 700 gauge. Okay, so these are for long term storage under cold storage conditions. So next is about seed storage. Seed storage, what I should need to discuss, precaution and everything. I hope like you can remember this. Don't worry about it. Sanitization, fine. Okay. During storage, we have the classification based on the longevity. So seeds are usually divided into three different types. One is orthodox seeds, intermediate seed, and recalcitrants. So this classification is based on the longevity during the storage. So I hope like you already know the clear-cut difference between the orthodox and recalcitrant. We have another term called as intermediate here. See, the orthodox seeds are those seeds which are both drying and freezing tolerant. Even if you just dry it, they are tolerant. Even if you just give the cold condition or freeze it, even they are freezing tolerant. So they are normally long lived. So opposite to it, recalcitrant, those which are not even drying tolerant or not even freezing tolerant. So we have another category in between this orthodox and recalcitrant, where they are usually drying tolerant to some extent, but they are not freezing tolerant. So that is why they are kept it as intermediate seeds. So these particular orthodox seeds can be dried to the moisture content as low as 5% without causing any injury, and they can also survive the sub-zero temperature. So this is freezing temperature, this is a dying temperature. Both can be survived by orthodox seeds. So these are most temperate crops or temperate species. At the physiological maturity, like moisture content of this orthodox seeds is will be 30 to 35%. Once it, if this moisture content can be lowered by seed drying, since it can be lowered until 5% of moisture content. It is observed that the intermediate seeds show the greatest longevity when they are dried between 45 to 65 relative humidity conditions. Talking about the recalcitrant, they cannot be dried, decreasing the moisture content below 20 to 30 without causing injury. If the moisture content of these seeds is lower to the 20 below 20 or below 30 percentage, this is the complete range. So there will be definitely the injury to the seeds where the quality will be deteriorated. Okay, and at the physiological maturity, the moisture content is very high here. It is about 50 to 70%, and it cannot also survive below 10 degrees Celsius, where this orthodox seeds can survive below sub-zero temperature. So these are the differentiation examples. Okay, this is the most important thing. Just try to remember these typical examples. Rest of all, it is of mostly the orthodox crops, orthodox seeds. So the rest of the things, in intermediate, we have few example, and also for recalcitrant, we have the few example. If you get any other examples from any authentic source, just verify the source before writing it here, and then write it. Okay, just include it only after verifying it clearly. Okay, because there are so many mistakes that you might see in these examples. I've just cross verified it very clearly and mentioned it. So if you get any other examples, just make sure to verify and then include it in this particular table. Okay, we got another questions which is related to recalcitrant and orthodox seeds. Just try to answer this question. Yes, like I have already marked the answer. It might be wrong also. Like just see that whether I have written it right or wrong. I'm just waiting for your answers. How many of you agree that 3 is right? I got 2 answers. Nice. Okay, A and B, very good. Okay, only 3 answers I have received. Like what about rest? I'm expecting some answers from you all since I have just explained this particular concept. Okay. So the first statement says that it is susceptible to desiccation. This is true, and susceptible to freezing. This is also true. Tolerant to desiccation. If the first statement is true, then obviously third statement won't be true. And fourth one is tolerant to for freezing. If second statement is true, then that fourth statement is not false. And fifth is always false. So it is A and B. I don't know, like you people are just don't want to answer it since it was simple, or I don't know what is the reason. I hope like you have understood it. So you might get a question. So when you just observe this three particular table, why actually recalcitrant seeds do not have this good storage capacity? Why they are the longevity is very less? So this is because of the reason that moisture content. The moisture content of these seeds are very high. So what happens? I told you like if there is a higher moisture content, it will encourage the microbial contamination. So there will be a rapid seed deterioration. So this is the first thing. So you might ask me like, okay, we not store this in a sub 0 degrees Celsius so that there won't be any attack of pests and diseases. So just imagine that the seed is having higher moisture content or higher water content inside. So if you just freeze it, is there any possibility that ice formation will take place inside the seed, ice crystal formation? So there is a process called as crystal formation that occurs because of excess quantity of the water is present. If you just suddenly drop the temperature of these particular seeds and bring it to the freezing temperature, due to the sudden drop of this temperature, you will get to see the ice crystal formation. So once the ice crystal is formed, it will disrupt the complete cell membrane and it will cause the freezing injury. So that is why they cannot be even stored at the higher moisture content, and they cannot be even stored under sub-zero like freezing temperatures. So freezing temperature, what is the reason? Because it will form the ice crystal, it will cause the ice crystal formation. So again, coming back to the question, why do these seeds have higher moisture content? What is the reason? So if you just observe this, these are completely covered with the pulp, juicy pulp or a fleshy pulp. So that is why the moisture content around the seeds is very high. I hope like I have answered your question. I hope like you have clearly got it why it is less short lived and why the moisture content is high and why they cannot be stored for under sub-zero or freezing conditions. And also naturally there is no dormancy kind of mechanism in case of recalcitrant seeds. So previously I told you that there is a dormancy, which is a natural adaptations or a evolved method where the seeds will survive for longer duration. But inherently, the recalcitrant seeds doesn't have any dormancy. Undergo dormancy, they will directly germinate once they come in contact with the soil immediately after the harvest. So what is the solution? How can we store this one? So once to induce the dormancy, we can use the external ABA that can be done to extend the longevity of these particular seeds, and also we can replace the moisture content by sugar or ethylene. So these are certain what you call elements or the compounds where they won't cause the crystal formation, ice crystal formation, when they are treated in the sub freezing temperatures. Only the water will cause the ice crystal formation, but the other substance like sugar and ethyl glycol, if they are replaced in the seed, they won't be causing any ice crystal formation. This is the second solution that we can incorporate. Or we have very common and familiar method of storing these recalcitrated seeds. So can anyone tell me if you know it, or if you can remember the method that we usually use to store the seeds, this type of seeds? It is again something related to freezing storage or freezing temperature. Have you not heard about the cryopreservation? This is cryopreservation is generally carried out in a liquid nitrogen at sub like minus 196 degrees Celsius. Okay, so this is how the recalcitrant seeds can be stored. It's not like suddenly there will be temperature drop to the minus 196. If it is done, like again the ice crystal formation takes place. Initially, like gradual decrease in the temperature will be done, and gradually it will brought up to minus 196. Okay, this is how these are stored. But the major disadvantage is we cannot store the bulky seeds, since the it is very costly. The cryopreservation is very costly, and it we cannot afford to occupy more space. So we need to handle it in a such a way that the material that we are going to store, it is not bulky and it is very short, simple and small. Okay. So there are certain factors which will influence the lifespan of seeds and longevity. I have mentioned it. I can just go through it once. Anything else? And these important points which I mentioned here, they are very much important for you all. They are very important. I have mentioned like what is the moisture content where the fungus, insects, molds will attack, and also like what should be the harvesting temperature and what is the drying temperature, and for the cereals, and also what should be the drying for sealed container, and also the seed moisture content, and what is the condition for the good storage, cold storage. It is below 60% RH. The good storage is nothing but like it implies the RH will be always less than 60%. And we have I've given the first cold storage started in the Kolkata. Just remember this. Okay. So according to the Arrington rule, if you have understood the Arrington thumb rules, so according to that, the RH, like the sum of RH plus the drying temperature or storage temperature should always be equal to 100, where the maximum can be of 50 and the maximum can be of 60 in case of RH. So if it is 60 here, the drying temperature or storage temperature should always be 40. If it is 50, it should be 60. Sorry, 50 or 60-40. So this is how it should be maintained, so that it is adding up to 100, and this implies the good storage conditions. So this is according to the Arrington's rule. Anything else? Okay, seed storage and seed storage, like storage fungi survives or is inactive below that 62% RH, and it shows less activity or little activity below 75. Okay. And storage bacteria, it requires around 90% relative humidity for the growth. Below it won't be surviving. And the insect and mites, it is seen that below 8% moisture content there is no activity, and they are generally active between 8 to 15% of moisture content. Insecticides, contact insecticide, DDT, Lendian, malathion. Also just try to remember what are the recently banned insecticides and also the fungicides. Just make a list out of it and just try to remember them. So the moisture content for storage is usually less than 14 for the starchy seeds, and it is more or less in case of oily seeds. If there are oils in the seeds, then the moisture content should be again very low. Because they are very prone to the attack of pest and diseases. Okay. This one, storage requirements. You can expect the questions from this particular concept. Storage of commercial seeds, how they are stored. These are from harvest to plant next year planting, and 70 to 80% of the produced seeds will be undergoing the commercial storage, and it is for 8 to 9 months. Next, we have the carryover seed. There will be 20 to 25% that will be left over after sowing, and this will be generally stored in the steel bins. Next, for the foundation seed stock, which is stored for 3 to 5 years. So the RH for this particular storage should be 25% at 30 degrees Celsius or less, or 45 at 20 degrees Celsius. Next, last category, we have germplasm seeds. So these are stored under commonly on coldest temperature. Why? Because they should survive for longer duration, for up to 10 to 15 years. So that is why they are always stored in the coldest temperature at 20 to 25 degree RH, and they will have a temperature of 5 or 10 degrees Celsius. This is specific for germplasm seeds. Temperature control, ventilations. Okay, I have seen one particular question. I don't remember which year paper it was. So they are asked like which are the good conductors, fair conductors, and poor conductors. I just try to made a list out of it. Just try to remember this complete list. Which are the good insulators, fair and poor insulators. Like poor insulators means they conduct the temperature, or they transmit the temperature very in the good way, or these good insulators are nothing but poor conductors. Poor insulators, this is good conductors. They conduct the heat efficiently. This is fair means this is in the in between. Just don't get confused. Good insulators means poor conductors. Good conductors is nothing but poor insulators. I think you people can read all these things. Nothing to explain. Cryopreservation. There is a one important technique called as cryopreservation, where even in the cryopreservation we follow two different methods. So one method is called as slow freeze procedure, and second method is called as vitrification. So in order to avoid cryopreservation, there is a problem of rapid freezing. I told you, like if suddenly there is a drop in the temperature, there will be a formation of internal ice, like ice crystal will be formed, or dehydration will have the effect on the seed cell membrane. So in order to avoid this, two procedures are followed, where first one I told you, like gradually there will be a drop in the temperature, or secondly vitrification. This is advanced method where very fast decrease in temperature without avoiding the intercellular crystallization can be occurred. This is particularly useful in case of recalcitrant seeds. So this is done by the transition of the aqueous solution of complete cytoplasm or cystole into the amorphous. Once they are converted into this glassy state or the amorphous state, they cannot form the ice. So taking the benefit of this particular method, vitrification is done. So if in the exam they ask you what is vitrification, it's just a physical process of very fast decrease in temperature, avoiding the intracellular ice crystal formation. So this is what you can say. So for vitrification, I told you, like storage of whole recalcitrant seed is difficult since it is very bulky. So the embryo will be excised, and once the embryos are excised, they are usually or generally encapsulated with the either calcium alginate, or this is the one chemical that is usually used for encapsulation. So once it is done, it will be dried in the sucrose solution, and then it will be immersed in the liquid nitrogen. So this is the most common chemical that is used for encapsulation of the excised embryos. Okay, so I have just given some of the storage structures. The storage structure, you might have heard about them. I don't know whether you have heard about this or not, but this is not necessary. Just leave it. If you can remember them, just go through it once. That this is not compulsorily necessary for this JRF. Lastly, we have gene banks. Okay. So the first gene sanctuary was started in Assam, which is a Garo Hills for wild relatives of citrus. This is particularly for citrus. So if you just see the classification, there are two different types. One is field gene banks and the seed gene banks. So seed gene banks, we have three different categories, where objective, it is depends on the objective, whether you want to go for short-term storage, medium-term storage, or long-term storage. The short-term storage for the working collection, which is frequently used, and the second one is active collection, which is only used for regeneration purpose, and the base collection, these are generally used for emergency cases, which are long-term storage. So this storage temperature and the years and the duration, these are very, very important. Just try to remember them. Working collections are generally stored under 5 to 10 degrees Celsius, for 3 to 5 years, and next it is 0 degree Celsius for 10 to 15 years for active collection, and for the base collection it is not 18, it is minus 18 to minus 20 degree Celsius for 50 years, not 5 years, sorry, 50 years. Okay, so this was that's it for today. I know like I have rushed the things, but I believe like if I just keep on explaining everything, it might just waste your time. I hope like I've just given an overview of all the things from the post harvest operations and what are the expected questions from this particular area. So just download these notes after the class and just try to digest the content. And after digesting it, you have to revise it from time to time. Otherwise, everything will evaporate. You won't be remembering anything at the end. Okay, I need some answers like whether it was too speed or it was okay, so that from the next class I will just decrease my speed. If you are feeling that I'm just going a little bit fast, or if it is okay, just say a yes or thumbs up. Okay, fine. So then we'll meet in the next class. So next class would be of seed testing. So that would be the last topic for seed technology. So apart from this, I have done all the analysis and checked all the previous year papers. I don't see like any other questions from out of the things that I am trying to give you. If you get any such type of questions either from the paper or from any model papers, you just can send me once. So if it is very much necessary and if I feel that I have skipped it, and I will definitely go with it and I will just compile the notes and I will again deliver that with you. Okay, so if there are no doubts, we will end the session here. So someone asked for xenia and metaxenia. I'll just cover it in the tomorrow's class. Okay. I told you about IMSCS, that is fine, and I also told you about the updating the notes, that I will do it now. So the way I have included the questions in between, I have also included for all other subjects, not all other topics of seed science. So I have incorporated already in the my notes. I have to just upload it in the app. Once it is done, I will just intimate you people, just go and download it. Okay, and the rest of the things, like someone asked me for the revision, like where to get the old lectures. It will be soon uploaded in the YouTube, might be within this weekend, so that you will get all the video lectures in a single playlist. Not to worry about it. There was a question in starting. Yes, thank you so much. It was regarding. Yes, thank you. I just completely forgot it. What was the question? Was it regarding the breeder seed, foundation seed, right? That is not present in this particular one. That is the question, right? Okay, thank you. So this is breeder seed. Foundation is A into B, into B comma R, and certified is A into R. If you are not understood what does this mean, okay, listen to me very carefully. So what is A line? It is a male sterile line. What is B line? It's a manteller line, and R line is a restorer line. So once you are doing the breeder seed production, you are giving your harvest, or you are giving the harvest to the next stage of seed multiplication. You are not giving into the commercial chain. So you need to just multiply the A line. So that is why A comma B comma R. You need to just multiply these three lines and give it to the next generation, that is foundation seed. Okay, so that is why in the whenever the seed production is started in the foundation seed stage by the ICAR institutes or other public sector institutes and the private seed companies or the farmers or under the intervention of the government, so they will take all these three lines A, B and R, Next, since they have got the handful of A line, but they have to produce again A line for the next generation, right? So how to produce the A lines? So can we just self the A into A? Is it possible to self A into A, or just self the A lines? We cannot do it. Why? Because they are male sterile. You will not get a fertile pollen out of it. So it should be always crossed with the B line to get a handful of A line for next generation. So that is why it is A into B here. Only if you cross the A line with the B line, you should isolate two plots where it consists of A and B. You should take the pollen from the B and just put it on the A lines, and then you should harvest the seeds of A line, which will be completely again A line. If you are sowed 10 seeds here, you will get 100 seeds. So this is how it works, right? So B line, this is not at all useful for the next generation. It is only for maintaining. So R line is nothing but selfing. You just grow it in isolation, you self it. You will just get a handful of seeds in case of next generation. So lastly, in case of certified seeds, why it is A into R, why it is not A into B? So once you just harvest this particular seeds, you will just sell those seeds as a hybrid in the market. So these are the hybrid seeds. So if these are the hybrid seed, farmer will go and sow these seeds, and he will get the F1. The F1 seeds are sowed, and this is what you will get, the yield. So that yield will be utilized for the commercial purpose or the edible purpose. So this is how he is looking at it. So this is how the seed production is done. The certified seeds are usually sold out for the commercial purpose, not for again the seed purpose, seed production purpose, right? So you need to cross them like A into R. That is what hybrid is, right? Like will cross the two different lines. Why crossing with R is necessary? So that it won't be sterile in the next generation. Since the R has a fertility restorer gene, so in the next generation, if this particular hybrid seed is sown, it can again pollinate and it can produce the seeds. Is that clear? Why it is A into R in case of certified seed, and why it is A into B and comma R in case of foundation seeds, and why it is ABR. See, at least for once you have to create A line separately, B line separately, and R line separately. Once you have created it, it's just the maintaining until certified seed production. So this particular thing, even I was not understood, like I was not able to answer this if you people have asked me during my preparation. Only after coming to MSc I got to know this point. Because generally, like no one in no book, like it is clearly mentioned about like it is maintaining in the breeder seed and foundation seed, and it is crossing in the certified seed. So we generally assume that okay, we just cross the two in breeder seed, we get the seed, again we cross the seeds in case of foundation, we get the seed, and lastly we again cross it. This is not a repetition of the process in case of hybrid seed production. This is only limited to varietal seed production, where the open pollination is allowed. In case of hybrid seed production, this is how it is done. 2 stages we will just maintain it, and 3rd stage we will just cross it. Clear, Archie and motion? Okay, good. So we'll just bring your doubts to me, anything related to seed tech, since we are dealing with seed tech, so that I can discuss it in a more effective way. Okay, so rest of the things we'll deal in the next class. I will upload these notes in half an hour. I will just intimate you in the group. You can download it and read it. Okay. Thank you all for attending. We'll meet in the next class.